Hello class. Today we're going to be covering how to conduct a hypothesis test of a claim about difference of a matched pair. To do that, we'll be in section 9.3 looking at number 1. Several students were tested for reaction times in thousandths of a second using their right and left hands. Each value is the elapsed time between the release of a strip of paper and the instant that it is caught by the subject. Results from 5 of the students are included in the graph, or below in our case. Use a 0.05 significance level to test the claim that there is no difference between the reaction times of the right hand and left hand. Now to do that, I'm going to be making a little table for us. And I already started, as you can see. We're going to have a table for how quick our right hand was and a table for how quick our left hand was. Or I should say a column for the right hand and a column for the left hand. And these columns are actually given to you on your notes. And we're going to have one more column, and I'm going to call that the difference column. I use D for difference. So the right hand's 116, left hand's 136. The difference is negative 20. If the right hand's 120 and the left hand's 133, the difference is negative 13. If the right hand is 149 and the left hand is 167, the difference is negative 18. If the right hand is 171, the left hand is 182, then the difference is negative 11. And if the right hand is 193, the left hand is 218, then the difference is negative 25. So by the looks of this data, everyone seems to be right-handed for this sample. Now this last column is the important one. That's the one we're using later. So let's start off, like we always do with hypothesis tests, with stating our hypothesis. So, to state this hypothesis, we need to determine what mu sub d is, state, define it, let people know what it means. Mu sub d is the mean of the differences. That last column, we're going to add them all up and divide by how many we have. Now that we know what mu sub d is, we're going to have our null hypothesis, which is h naught, which always has an equal to sign. So we're going to say mu sub d is equal to 0, which means there's no difference on average. The alternative would be mu sub d does not equal 0. Now that we have the hypothesis test out of the way, let's do our test statistic. And like with any test statistic, we need our formula. So we have T equals d bar minus mu sub d all over S sub d divided by square root of n. Now we can find these values from the D column, that right hand column. So D bar is equal to the mean of our differences, or the mean of the D column, which would be negative 17.4. S sub D would be the standard deviation of the differences, or the standard deviation of D column, which would be approximately 5.59464003 roundabout. Just write as many decimal places as your calculator gives you. N is our sample size, so that would be 5. So let's fill this in. That's equal to negative 17.4 minus 0, because we assume the null hypothesis is true, and that said that mu sub d was 0. That's all over 5.59464003 divided by square root of 5. We can plug it into the calculator, and we're going to get right about negative 6.954. Now that we have our test statistic, let's move on to identify the critical values. Now with the critical values, there's a couple things we need to keep in mind. We need to know what kind of tail test this is, what is alpha, and what are degrees of freedom. Our tails would be a two-tailed test. Since this is not equal to 0, it could be either less than or greater than. We also know that we have a 0.05 significance level, which means alpha is 0.05. Degrees of freedom is given by n minus 1, so for us that'd be 5 minus 1, which is 4. Now let's look in that t-table. When you look in the t-table, degrees of freedom 4, alpha 0.05, we get our critical value to be 2.776. And since it's two-tailed, it's the plus or minus, so plus or minus 2.776. Remember, it has to go both directions. Now, to finish this up, it's time for the conclusion. For our conclusion, I'm going to sketch this normal distribution curve. And these little areas I'm shading are the two tails. Anything in these tail areas, we will reject H0. Anything between in that open area, we fail to reject. Our test statistic was negative 6.954, and that's going to fall over here to the left. Negative 6.954. Now since it falls in that tail, that tells us we will reject H0. If you have any questions about how we found this value or how we knew what to do or read the table, please contact me or post in the discussion board.